The topic that we'll be looking at today is quadratics. So before we get started, I want to talk about the three types of quadratic equations or the forms that we will cover today. So the first type is the general or standard form, which goes as y equals ax squared plus bx plus c. Now we will go over what each of these letters mean later on, but let me first introduce two more types of these formats. The second type is the turning point form, which goes as y equals a x minus h squared plus k. And the third type, which is similar to the standard form, is the intercept form, which goes as y equals a x minus x1, x minus x2. Now we will look at each of these in much greater detail later on, but let me first take your attention to this graph here. This is the standard graph of the quadratics that we'll be looking at. And as you can see, this is the graph of y equals x squared. So example, if this is 2, when x is 2, and this is my equation, y equals x squared, then what would y be? So y would be 2 squared, which is 4. And if we check on our graph, that point there is 2, 4. Now, since the squared is the whole x term, that's why our y values are mirrored over the x line. So if I look at negative 2, when x equals negative 2, and then y equals brackets negative 2 squared, which again is 4, and hence the symmetry over the line here. That point there is negative 2, comma 4. And these two go to infinity, and this is your standard graph. We will also be looking at dilations, reflection, and rotations, but all of them are built upon on this base graph. And so if we look at the standard form, I'll rewrite that here. So my standard form, this is what you'll be looked at most of the times. This is what you'll be shown or asked. And now, using this format, we can calculate different things of a quadratic. For example, if we were to sketch this quadratic, then we would need some key points. So if I just take that graph and bring it here so it's clear. And what are the key points here? The key points of a graph, key features, would include concavity, x and y intercepts, the vertex, and that's pretty much it to get started and have a rough idea of what the graph would look like. And what do I mean by concavity? So let's further build on that. So concavity refers to the value of a. And which a am I talking about? It's this a that goes in front of the x squared. And concavity basically says that if my a value is greater than 0, that means my graph goes up like that. And if it's negative, for example, and if a is less than 0, then my graph would be a maximum. So this is a minimum graph because my turning point is at a minimum, and this is a maximum graph because my turning point is a maximum value. And when I mean minimum and maximum values, I'm referring to the y values at the turning point. And that's basically what concavity means. And this gives us a rough idea of whether we should calculate or worry about the x-intercepts or not. For example, if my graph was positive, let's say, and I know my turning point is 2, 4, so somewhere over there, and I know that the value of A is, let's say, it's greater than 0, that means the graph goes up like that. And that gives me a rough idea that I don't need to worry about calculating the x-intercepts because that's just going to waste my time. But as always, we should focus on the y-intercepts because they always exist. So that's the first step, concavity. Now, x and y-intercepts, obviously, we need to worry about them because we need to know where the graph cuts those lines. And how we do that, so to give you a rough idea, the steps would be to calculate x-intercept, we have to we let y equals 0. So this step, letting y equals 0, is really important. Otherwise, you would lose a mark in an exam because the examiners need to know why are you letting y equals 0, and that is because you want to find the x-intercepts. So how you would normally write that is for x, let y equals 0, and here we look at a equation here, and we substitute y as 0, and then we rearrange the equation to solve for x. And this for calculating the x-intercepts. But what about the y-intercept? For the y-intercepts, it's the pretty much the same thing. So we say to calculate the y-intercept, we let x equal 0. And how we would normally write this in a question paper or an answer to the question would be for y now, we let x equal 0. And how we would do this in an actual question would be we come to this equation, and wherever we see an x, we just put a 0 there, and that should give us the y value as this plus c. But more on that later on. The last thing we will talk about in the standard format is the vertex. Now, with the vertex, before we look at the vertex, let's look at the axis of symmetry. And now, what do I mean by axis of symmetry? So, for example, if my graph is, let's say, it looks like that, then my axis of symmetry is where this graph is cut into two equal or symmetrical parts. And let me just label that as x equals h. So this is what I mean by axis of symmetry. It's where my graph is divided into two equal bits that mirror each other. And that is really important because my vertex, so my vertex or the turning point always lies on the axis of symmetry. Because if you think about it, the vertex is the minimum or the maximum point, which is always on this particular line. But the question is, at what y value? And for that, we need to worry about this equation here. But let me calculate the axis of symmetry first. So this is my standard format. And for the axis of symmetry, the, the formula is x equals minus b over 2a. Now there's a reason why this is minus b over 2a. And let's take a little detour to worry about where does that come from. So this particular thing here, we'll talk about this later on, but I'm just going to introduce it right now, which is called the quadratic equation. And you'll need this, or the quadratic formula, better called, which is minus b plus minus the square root of b squared minus 4ac all over 2a. Now this is what we will be using for solving quadratic equations, solving quadratics. But I want to introduce this now because this minus b over 2a, if you look at it closely, is is this part over here. And the quadratic equation or the formula, what does this actually mean? This is for finding, let me just change that to black. This is for finding x-intercepts. So if we break this formula down, minus negative b over 2a is my axis of symmetry. So let's just say it's over there. And the plus minus square root of b squared minus 4ac. This this bit here tells me how far left and right do I need to move from my axis of symmetry. That's what the plus and minus is there. Plus because moving right hand side, minus because I want to move left hand side. So if you look at that intuitively, that tells me that the point where I'm starting from is minus b over 2a. And then, let me write that properly, 2a. And then I'm moving uh, b squared minus 4a units there, and b squared minus 4ac units there, left and right side. And this is where this formula comes in for the axis of symmetry. But for now, we will not worry too much about this. I don't want to confuse you. We will come to this when we are actually solving the quadratic equation. So if you don't get this, that is fine. But we will come to that later on in a few lectures time. So this is the axis of symmetry, and for the vertex, as we saw before, that the vertex lies on the axis of symmetry. So the axis of symmetry gives me my x value. So we have to use the axis of symmetry to find the y value of the turning point. Because if this is my graph, and I just calculated that uh, this x value is minus b over 2a, but I still don't know what this y value is there. And how would I find this y value? I have to substitute the minus b over 2a as my x value in my equation here. So when I substitute minus b over 2a. When we do this, we will get a particular y value, and that will be my turning point. So I can say that the turning point is minus b over 2a, and then f of minus b over 2a, where f is, we can write that as f of x. So that's enough theory. Now let's actually do a practical problem together. So let's say if the standard format was 4x plus 12. And the question is to sketch this graph. So sketch the following, or sketch the graph. So let's break this down first and talk each of the steps thoroughly. So the concavity of this graph. So what's my coefficient of the x squared term? If there is nothing there, there's always a 1. That means that value of a is 1. And since 1 is greater than 0, that means my graph goes up like that. So that's the first step done, that the graph has a minimum value. Now let me calculate the x and y intercepts. So I'll calculate the y-intercept first. So for y, let x equal 0. This step again is really important. That means wherever we see x, we just put in a 0. So that's y equals 0 squared plus 4 times 0 plus 12. 0 squared is just 0. 4 times 0 is 0 plus 12, which gives me 12. that tells me that the y-intercept is 0, comma 12. Now that's the y-intercept done. Y-intercept done. Now let me calculate one or multiple x-intercepts. So the x-intercept would be for x, let y equal 0. So we let y as 0 equals x squared plus 4x plus 12. And now we have to solve this using one of the methods. So how we will actually solve this, there are multiple ways we can solve this. There's factorizing, there is completing the square, there is groupings, and if none of those work, there's always a quadratic formula. So we'll talk about all of them later on in the future lessons, but since I already introduced quadratic formula, actually let me show you a different way. So x squared plus 4x plus 12 equals 0. So I need to find two numbers that times to 12 and that add to 4. Hmm. So uh, on top of my head, I can't think of two numbers. So in an exam situation when this happens, you wouldn't want to spend too much time here and just go straight into the quadratic formula. So I get 0 equals, and the quadratic formula is x equals minus b plus minus the square root of b squared minus 4 all over 2a. And in my equation here, my a is 1, my b is 4, and my c is 12. So I get, my b value was 4. This is negative 4 plus minus the square root of 16 minus 4 times 1 times 12 over 2 times 1. And that gives me negative 4 plus minus the square root of 16 minus 4 times 12, that's 48. And that's negative 48 all over 2. This gives me negative 4 plus minus the square root of 16 minus 48, which is negative 32. Uh-oh, we are at a problem. So now, square root of negative 32 doesn't exist. And not in real numbers anyway, but we are now looking at complex numbers. So if you look at this step, we say that since square root of negative 32 does not exist, therefore there are no x-intercepts. And this is not ideal in an exam situation because you wouldn't want to spend so much time calculating and then ending up not finding an x-intercept. So what we can do there is before we calculate the x-intercepts, we can check for the discriminant value, which is b squared minus 4ac. And if this is negative, then that tells me if the discriminant is less than 0, then that means there are no x-intercepts. If the discriminant is equal to 0, then that means there's one x-intercept. And if the discriminant value is uh, greater than 0, then that means there are two x-intercepts, or two distinct x-intercepts. Intercepts. And since we just worked it out here that the discriminant value was negative 32, which is less than 0, then there are no x-intercepts. So we calculated the y-intercept was 0, 12, and there are no x-intercepts. So let's look at the vertex. And for the vertex, I will need to know the axis of symmetry first, which is minus b over 2a. My b value was 4, and my a value is 1, which is negative 4 over 2 times 1, which is negative 2. So that's my vertex, and now let me find my, so that was my axis of symmetry, x equals negative 2. And for the vertex, I need to substitute x equals negative 2 back into my original equation of y equals squared plus 4x plus 12. So wherever I see a x, I just put in negative 2. 4 times negative 2 plus 12. Negative 2 squared, that's negative 2 times negative 2. Two negatives make a positive, which is a 4. That's 8 plus 12. 4 minus 8 is negative 4 plus 12, which is 8. So my vertex is negative 2 comma 8. So if I put all of those pieces together, um, so let's say that negative 2, 8 is somewhere over there, and my y-intercept was 0 comma 12. So let's say 12 is somewhere over there. The graph would look like, oh, let me draw that again, a bit better. Actually, hold it. If I just draw it a bit narrower, that should do the trick. There we go, that's better. So my turning point here is negative 2 comma 8, and my y-intercept was 0 comma 12. And with that, that was our first graph